We're going to process some T2 data today using both the macro to auto-process the data and then manually doing the fits. So we'll go to the File menu and choose Run Macro. It's using the right-click menu. The macro we want to run, of course, is the Proton T2 macro. It's going to query us what file do you want to process. I have one right here called Tom T2. Ask me for a line broadening value for Proton. I generally don't use any line broadening. And you'll see that this comes up in a stack plot. I'm going to hit enter to get out of the stack plot and just zoom in a little further. And then use the two-letter command SP stack plot to show you what this data looks like. You notice that the ones closer to us, further down on the screen, are the highest intensity. Those were the first ones collected. The last one at the top is the last one collected, very low intensity, lost almost all coherence. I'm going to hit enter to get out of the stack plot mode. And when you are processing T2 data, we're going to do one resonance at a time. So let's take a look at this middle resonance because it's all alone, real easy to do. We're going to enter the zoom command and kind of take a broad swipe at it, but what you want on the screen is just the peaks that you want to integrate. There's too much baseline on either side of this. So I'm just going to go to an area that looks like it's a good area to integrate. I'm going to hit enter to get out of the zoom subroutine. And then there's a series of two-letter commands that you have to initiate. The first one, GR, get relaxation data. That just went through and integrated each slice in the region that is shown on the screen. The second two-letter command is DR, like display relaxation data. And you notice that we get these squares on the screen indicating what the integrations were for the different peaks. You can go to the Fit pull-down menu and choose what fit function you want. In this case, we're going to use T2 single decay. You notice that it's set to area. Area is always better than peak height or interpolated height because peak heights can change generally, but area is very consistent. So we'll click OK, and then we're going to just type the letter O, or under the Fit pull-down menu, optimize curve fit. You can hit O a couple times. Notice that the T2 is listed in the bottom right-hand corner, 2.887. Notice that the green fit line goes through most of the points, doesn't go through the last two, which isn't unusual. Those aren't very good data points. I'll show you that in just a second. What you see on the screen right now is the 9th slice. I'm going to show you the full spectrum. You see what that looks like compared to, here's slice number 6. Looks a little more reasonable. Slice number 3, slice number 1. As time goes on and we start losing coherence, the peaks get a little broader at the base, and it just doesn't look as good. So those last two data points that you see during the curve fitting, they don't always fit. So don't be too surprised that you don't get a very, very good fit. Let's integrate another peak on the screen. We're going to enter the zoom subroutine, take a broad swipe, and then fine-tune what we want on the screen to integrate. Get out of the zoom subroutine. We're going to initiate the data reduction, GR, to get the relaxation data, DR to display the relaxation data. Notice this last point over here is actually negative. That's not too good. We'll go to the fit function, still set to T2 single decay, and then fit, optimize curve fit. Hit O a couple times. Notice down here in the bottom right-hand corner, the T2 is 3.255 seconds. So within a molecule, each resonance will have its own T2 and, of course, its own T1. So that's not unusual to have multiple T2s within a molecule. Let's do this one more time. We'll go back to slice 1. Broad swipe, narrower swipe, GR, get relaxation data, DR, display relaxation data. Make sure the fit function is set to single decay, and then optimize curve fit. OO. Notice the last 2 points aren't fitting. That's not too unusual. 4 seconds, 4.019 seconds is the T2. So in a nutshell, that's how you process T2 data using the SNAP program.